Okay, so in this example, we're being asked to find the rotation of a bicycle wheel. And it tells us that the angular velocity of the rear wheel of a stationary exercise bike is 4 radians at a time per second. And then the time equals 0, and the angular acceleration is constant and equal to 2.0 radians per second squared. It also says that a particular spoke coincides with the positive x-axis at time t equals 0. So it's asking us, what angle does the spoke make with the positive x-axis at time t equals 3 seconds? And what is the wheel's angular velocity at this time? So we're being asked to solve 2 parts here. So for the first part here, we're being asked what angle does the spoke make with the positive x-axis at this time. So to start that, we need this equation where theta equals theta 0 plus the initial angular acceleration times the time plus half of the average angular acceleration and times t squared. So we just plug in all the values that were given to us. We know that initial theta is 0 plus the angular acceleration is 4 radians per second times time 3 seconds plus half of the average angular acceleration is 2 radians per second squared, and then the time is again 3 seconds, and we square that as well, and this ends up being 0 plus 12 plus 9, and that leaves us with 21 radians. And then if we want to convert the radians to revolutions, we would do 1 revolution is equal to 2 pi radians, because 2 pi is a full 360. And this would leave us with an angle of 3.34 revolutions. And now for part B, we're trying to find the wheel's angular velocity at time 3 seconds. So for the angular velocity, it's a much simpler equation. The angular velocity would equal to the initial angular velocity plus the average angular velocity times the time that we're being asked to look for. So again, if we just plug these values in, it's 4 for the angular velocity plus the average of 2 for the acceleration times 3. And that would leave us with 10 radians per second for the wheel's angular velocity.